Hello, everyone. I'm so happy to come your way again. I hope you are keeping okay. Right, we're going to be looking into a question that someone asked following my last video on linearity. Okay, so what then happened was that there was a question asked, and that was because remember we had looked at linearity, and I mentioned the fact that linearity has to do with the straight line standard curve or calibration curve, as the case may be. I had called it the analyzer comfort zone. Okay, so basically, meaning that every result you get, every result the analyzer give you, it would have to derive it. It would have to derive it from the analyzer calibration curve or standard concentration curve, if that makes sense. Okay, so that is why it's called analyzer comfort zone. What that means then is the fact that any result that you get that is outside that comfort zone, outside that calibration curve, that means that result has failed linearity. In other words, it is outside linearity. Okay, so and I did said during my last video that any result that you obtain that is outside linearity, you cannot trust that result. And that is why when analyzer thinks that a result is outside linearity, it will prompt you that this result is outside linearity. That way you can do something about it. In most cases, when that happens, that it has failed linearity or it is outside linearity, in most cases, it would have to be that the analyte concentration is very high compared to what the sensitivity or the calibration curve or the standard comfort zone curve of that very analyzer. So it's usually a concentration being high that will make it to fail. So I have received a question that, okay, what if there is interference like haemolysis, like lipaemic, like icterus? Would that also interfere with linearity? Would that cause force raised or force out of linearity because the sample is haemolysed or icterus or lipaemic? Okay, and if yes, what can we do as a biomedical scientist to make sure that we give out an accurate result? Okay, so that is fine. So we're going to look into that now. Okay, but before we continue, please, if you've not subscribed to this YouTube channel, can I kindly ask you to subscribe, and don't forget to like and share and also comment. Okay, so now let's get into that. My name is Dr. Manuel Obodo. I'm a senior biomedical scientist and I'm also a lecturer in biomedical science here in the United Kingdom. So having well understood the linearity now, okay, I feel like the best way to explain what I would want to say regarding the impact or the interference of hemolysis, icterus, or lipaemic on the overall result that you get, especially when it comes to causing or attributing to the result of the concentration of the analyte failing the linearity, I think I would prefer to give you my explanation using image. Okay, so let's get into that. Now, if you look at this, I'm not sure if you can see this very well. You're going to see that this is a normal serum and this is hemolyzed serum. I just decided to use these two to give you explanation of what I'm trying to explain. Remember, if you can remember, in biochemistry especially, there's what we call blank. Okay, so if you want to adjust the reading meter, the sensitivity or what the analyzer or the equipment you're using to measure, if you want to adjust its reading, you use the blank. That means you can use the distilled water, basically something that is neutral, that has nothing of what you are trying to measure. That is calling it, you are zeroing it. Okay, you are bringing it to zero. The same thing if you want to weigh something. Let's say you want to weigh sodium chloride, or it doesn't matter, anything you want to weigh in gram. What do you do first? The weighing balance, you put it to zero. You zero it. When you zero it, you are calling it blank. Okay, even if you put something like paper on top of it and you zero it, that is blank. Okay, so what it then means is that when we are calibrating our analyzer, okay, when we are generating the standard curve, when we are generating the linearity of the analyzer, we are using something like this normal serum. You can see the normal serum now. I'm just giving you an example, okay? You can see this normal serum. Look at the color of this normal serum. Now look at the hemolyzed serum. So when you compare these two, you see that that is wrong. In other words, you generated the straight line curve, you generated the linearity using this normal serum. If you now get outside linearity because of hemolyzed serum, the problem is not the analyzer. The problem now is the sample. I have my reason for explaining that. Okay. So let's go again. So when we are doing calibration curve or standard curve, okay, when we are trying to generate the linearity, what we are trying to do is to use a serum that is consistent with what is expected under normal condition. Okay. So because of this serum you are seeing here has been used to generate the standard curve, has been used to generate the calibration curve, now has been used to generate the linearity, okay, the straight line graph. What it means is that any result that is not consistent with a normal serum would interfere on that very sensitivity, will interfere on that measuring ranges. Why? Because it has been measured and the linearity has been generated using a normal serum. So what it means that if I compare these two, if this hemolyzed result gives me outside linearity result, in fact, even if it doesn't give me outside linearity result, let us assume, before we even get to the linearity, let us assume that the hemolyzed result is still giving me, hemolyzed sample is still giving me a result within linearity. I can't trust it. Why? Because what I'm measuring, that hemolysis would have interfered on the result I'm already getting. Maybe I should explain it this way. Let us assume that the linearity is between, let's say, 5 to 20, okay? Now, under normal condition of this hemolyzed sample, maybe ideally the concentration, let's say the concentration of glucose on this hemolyzed sample, for example, or maybe let me use creatinine, okay? Let's say the concentration of creatinine on this very hemolyzed sample should be maybe, let's say it's supposed to be 500, which is supposed to be within the linearity, for example. Because it is hemolyzed, I might get 550, it may add 50, I might get 600, it may add 100. But that 100 that it added is still within the linearity. That does not make that result correct. In other words, that you get a result that is within linearity does not also make the result correct. That is why in validating result, one of the things you have to consider is pre-analytical. You must check that the sample you are analyzing is within the condition, acceptable condition, for you to be able to finally authorize or release that result. So I want to put that out there first. So let me say this again, that a result is within linearity does not all the time make that result correct. If the sample is hemolyzed, high bilirubin, or icterus, as a biomedical scientist, you have to, use a scientific judgment to check that the hemolysis or high bilirubin or a high lipid has not negatively impacted on the result you want to release, even though the result is within linearity. I think I'm already getting close to answering this question. So let me go again. So we calibrated using this serum. What it means that when you analyze something that is hemolyzed like this, you should expect that the interference of this hemolysis would impact negatively, will give you a false result. Even if that false result means that it is outside linearity or within linearity. Okay, now, if you look at this other one that is well labeled by chemistry lab interference, you're going to see there is 4 tubes here. In these 4 tubes, the first one is normal. The second one, followed by the blue one here, labeled blue one, is normal serum, okay? Now, the green one is lipemic. You can see the picture. It's lipemic. The serum is lipemic. Now, the middle one is hemolysis, okay? Then the gray one, the one labeled gray, is what? High bilirubin. So you can see the serum as well, okay? And this can also be replicated in plasma, by the way, okay? So now, looking at this, comparing this with what I had explained with this one, you will see that, look at this normal serum. This is what we use in a quote. That means that is ID sensitivity. So anything that analyzer is measuring, the comfort zone of the analyzer, the detection, the measuring ranges of the analyzer, the sensitivity of the analyzer has been zeroed to measure something that is this normal serum or plasma. Does that make sense? Okay. What it means that anything that is outside this normal serum or plasma would interfere on the sensitivity of that measuring range, therefore may give you a false result. Okay, false negative or false positive result. Therefore, when you get a result, when you get a sample rather that is hemolyzed, that is high icterus, that is lipemic, okay, you would have to consider that first before you make your decision. So in saying that, I want to say that that yes, lipemic, icterus, haemolysis will certainly affect the sensitivity, the comfort zone of the analyzer or the calibration curve or the standard curve. In other words, if sample is highly hemolyzed or if sample is highly icterus or highly lipemic, it can cause the linearity to fail. It's not because the concentration of what you are measuring on the analyte is high. Is because of the condition of the sample. So the condition of the sample, like lipemic, icterus, or hemolysis, can lead to high results, can cause the linearity to fail. And when the linearity fail, is not because of the patient condition or concentration of what the patient has got, is actually because the condition of the patient has made the sample to be lipemic, to be icterus, or to be hemolyzed. And in such cases, you have to treat it with caution, which I'm going to explain further. Okay, let me stop you there, okay? Now, I want you to do me a favor, because the statistics of this YouTube channel suggest that many people who are watching this YouTube channel, they are yet to subscribe, okay? Please do us a favor. Do me a favor, subscribe if you have not done so, and don't forget to share, like, and comment. That way, it can take this video to many people that this video will help. So together, we can help colleagues to be able to locate this video and get well prepared when preparing for their what? Their interview in biomedical scientists, or as the case may be. Also, I wrote a book, okay? And I believe that this book will help you if you are preparing for your interview. I want to kindly ask you to go on Amazon and get this book. I'm also going to put a description on this YouTube channel so you can, directly purchase from Amazon. Okay, let's get back to the video, okay? Now, I want to show us something that I put on a table. I put this on a table because I believe it can help us, okay? So now, this is for us to first of all look at what is a true linearity, and also look at the interference due to some of these things we've mentioned, like hemolysis, icterus, and what? Lipemic, okay? Right. So if you look at this, you're going to see that if it is a true linearity, in a case where it is a true linearity, you are going to see that the analyte will exceed analyzer measuring range. That is when you say it has failed the linearity. So it has failed the linearity when the analyte, okay, exceed the analyzer measuring range. Against, if it is interference due to hemolysis or lipemic, or as the case may be, you are going to see that the sample quality will affect measurement. I want you to note the difference. When the linearity is failed due to sample quality, it does not mean that the concentration of the analyte exceed the measuring ranges, okay? However, what it does mean is that the sample quality, okay, has affected the measurement. That's the difference. So when sample is hemolyzed, icterus, or lipemic, that quality of that sample is what that can affect the measurement, and in affecting the measurement, it can give you false act of linearity, okay? So, and I want you to treat that with caution, which we are going to look at. So now let me go again. If you look at true linearity issue, is because the analyte exceed the analyzer measuring range, while if it is interference, it means that the sample quality affect measurement. Then number two, you will see that if it is true linearity, you are often going to solve the problem through what? Dilution, okay? Like I had mentioned on my previous video. However, if it is due to interference like lipemic, icterus, or hemolysis, as the case may be, the dilution may not resolve the problem, okay? Because the sample is already hemolyzed. Does that make sense, okay? Or icterus or high jaundice. In fact, if you continue to dilute it, you are likely to get even more false result. Result you're going to get is not reliable. Why? While you're diluting the lipid concentration, or you're diluting the hemolysis, or you're diluting the high bilirubin, you are also diluting the concentration of what you are looking for, which is wrong. So what you want to do in dilution is only dilute what you are looking for, okay? Not to dilute the quality of the sample. So that you dilute lipemic does not mean that is you are going to get a wrong result, because you are doing two things. You are trying to dilute lipemic, not the concentration of the analyte. Does that make sense? So when sample is lipemic or icterus or hemolysis, diluting it because it failed linearity may not be the way to solve the problem, okay? So because you are not really focusing on the concentration of the analyte, okay? Now your dilution may further dilute what is not high to become even low. So let me give you an example. Let's say the concentration of the glucose supposed to be normal, okay? But the sample is highly lipemic, okay? So if you try to dilute it because the sample is highly lipemic, the normal glucose will now become low. Do you get the point? Because as you are diluting the lipemic, you are also diluting the concentration of the analyte, which originally was not high. It was actually normal. So, and that can give you a false low result, and that is not what you want. So when it is a quality of the sample, we have to treat it with caution, okay? So I'm trying to say that if it is true linearity issue, it means that often you can solve it with dilution. But if it is due to interference, diluting it may not solve the problem. Now, I give you an example. Let us assume a situation whereby creatinine is greater than 1,500 micromole per liter. So when creatinine is greater than 1,500 microliter per liter, 1,500 microliter mole per liter, now because it is higher than each measuring range, that is why it is a true failing of linearity. However, I want you to see the other way around. Let's say in full blood count especially, when you get high lipemic, the serum, or sorry, the plasma is highly lipemic, okay? It can also happen in coagulation, even in biochemistry. So that is highly lipemic, but I'm using this because that will make more sense. So in full blood count, lipemic sample can make the MCHC to be high. It does not mean that the MCHC is high. The same way, if sample is lipemic, if sample is hemolyzed, okay, let me also give you another example. I think in biochemistry, in a hemolysis of the sample, you can get false potassium result. So the false potassium result you are getting is not because the patient potassium is high, it's because the sample is hemolyzed. Do you get the point? So in other words, the hemolysis of the rate of the hemolysis of the sample can cause the potassium to fail linearity, but not because the patient potassium is high, it's just because the sample has been hemolyzed. And that is the point I want to make here. So if it is interferent issue, it can lead to false raised result, even though the patient sample or result supposed to be what? Normal. Okay? All right. So when it comes to the true linearity issue, result may be accurate after dilution. So if it is the genuine due to concentration of the analyte being high, you can get a reliable result after dilution. However, if it is not genuinely high, interference must be addressed first. So the bottom line of what I want to say is this. If you notice that your sample has failed Hill test, hemolysis, lipemic, and icterus, and it failed linearity, your problem at that time, or the challenge at that time, is no longer linearity, is the sample, okay? And the quality of the sample is what you need to focus on, not the linearity. So I will not suggest that you should dilute, because diluting it, you are solving one problem, but you are creating more problem, as I've already explained, because you are going to be diluting perhaps something that concentration is normal to become low, while you are trying to solve the problem of the hemolysis or icterus or lipemic, as the case may be. Therefore, if you run a test and it fails linearity, and you get the sample and you notice that it is highly hemolyzed, it is highly lipemic, it is highly icterus, what do? Your problem is not linearity. What you do is to reject that sample. Okay? If you can't reject the sample, you then have to find a way to elute, to remove, for example, in the case of lipemic, as the case may be, you need to find a way to elute that very lipid before reanalyzing, rerunning that very test. Because if it fell If it failed linearity due to interference, as we have mentioned, until you first of all deal with that very linearity, you can't solve the problem. So to answer your question, yes, lipemic, icterus, haemolysis can result to force raise or out of linearity, okay? But to deal with it is not to dilute it, okay? Because your problem is the quality of your sample. So, and that is what you have to address first. So, my own opinion, I would say, of course, that has happened to me many times. If I get something like high lipemic, especially in coagulation, once I see the lipemic, there's no need of running it. Once I see lipemic, there's no need of running it. What I'm going to do is just to reject it, because I'm not going to get anything that is reliable. So what? Remember, as I end, remember that what a biomedical scientist is doing when you are validating results, you are examining every result where possible, that this result you are about to release, that there is no interference, that nothing has impacted on this result that can make you to, that can give a clinician or the doctor a wrong perspective to make a wrong clinical judgment. Maybe I should put it this way. If I'm validating a result and I notice that, okay, how will I put this? Let's say it's high bilirubin, okay? And I'm validating the result, and I think that high bilirubin would have impacted on the result, but I think it has not impacted it so badly. I can still release the result, but I'm also going to put a comment. Note, high bilirubin or sample appear highly icterus, okay? Please consider when making a clinical decision. It's very, very important, okay? Because once you release the result, the clinicians take it that result is reliable. Therefore, when you run a test and you notice that the linearity has failed, the first thing you do is to get your sample first. Check the sample, spin it down or centrifuge it. Make sure that the sample is okay. If the sample is okay, then you can further do the dilution as we have discussed before. But if the sample is not okay because it's hemolyzed or icterus or lipemic, at that point, it's no longer about linearity, it's about the quality of the sample. Therefore, in my own opinion, using your own scientific judgment, you have to look at what you can do. But generally, you may have to reject that very sample, okay, and let them know why you are rejecting it. I hope that makes sense. Okay, please do let me know what you think about the video. Put a comment on the comment section. Let me know if there is something else you want me to talk about. I already have some topic that people want me to talk on, which I'm going to do, of course. But yes, do let me know if you have another topic that you want me to talk on. And thank you so much for the person that requested for this video. I hope that has helped. If it has helped, also let me know on the comment. All right, thank you so much. And please don't forget, subscribe if you've not done so. Share this video, like, and also comment. Together, we can help colleagues to be able to, see this video, and it can help them to prepare better when they are getting ready for their interview. And don't you forget, if you've not bought this book, buy it. It's on Amazon. And I'm also going to put the description on the video link. All right, thank you. Till I come back away again. Bye-bye.